Assalamu alaikum, this is Muhammad Khair, math teacher at KKI Schools. Our lesson today 9-1 quadratic graphs and their properties. And our objective is to graph quadratic functions of the form y equal ax square and y equal ax square plus c. Let's go. Okay, here we have this question: graph the parabola, identify the vertex. Let's go. I will graph this, my dear student, this quadratic equation, and you know the quadratic equation, it is any function with power 2, okay, or the highest power in this function is 2. We call it quadratic. And also one more thing, the parents for all the quadratic function that you take it now and later is y equal x squared. This is the parent, and it is a graph, my dear student. Okay, I don't have it here. Okay, it is very bad. No way. Okay, and it is a graph is look like this, the big U. Okay, this is the parents for all quadratic equation. Okay, let us start how we can graph any quadratic function. Easy. Okay, first of all I will take this, okay, which is y equal, this is my quadratic. I will graph it. The first step, I draw my table. Okay, I I will cut it into only 2 parts and do this. This is the x and this is the y. Okay, actually I will take 2 values. Okay, yes, only 2 values. Okay, because I will take 1 and 2. Okay, so the 1 and the 2 from where, teacher? It is from my head, and you can pick any numbers from your head. Are you happy with that? Good. Now what we have to do to get the y values here, teacher, we have to put the 1 here, this one instead of x. Okay, let's go. So y equal -3, okay, 1 square. Like this, yes. So you have to multiply the 1 by the 1, and this is give me 1, and -3 by 1 equal -3. So this value will be -3. Are you happy with that? So the first order pair, my dear student, is 1. Yes, 1 and -3. My dear student, this is the 1 and this is the -3. Are you happy with that? I hope so. The second step, now the 2 term, I will bring the 2 here. Okay, so y equal -3 multiply, there are hidden multiplication here, multiply 2 square. Okay, 2 square. 2 square, that means this one, it is 4. 2 multiply 2, remember that. So -3 multiply 4 equal -12. So here we have -12. So the second order pair is 2 and -12. Are you happy with that? Me too. So now we have to plot this 2 order pair. Let me clean them. Okay. Okay, it is -3. And this is the one. Okay, now I will plot them in the xy coordinate. You know the xy coordinate, you take it in grade 4, my dear student. I know you know. So I will do this and this. Now I will start with this one. How I can read it? 1 to the right and -3 down, so it will be here. Okay, again 1 to the right and -3 down, so it will be here. Okay, my dear student, the second point. Okay, now if you plot the first one, يا مرحبا بذكر الله, if you plot the first order pair, you have to find the reflected point. Okay, so the reflected point around the axis of symmetry, which is this is called, my dear student, this is called axis of symmetry. So directly, if you draw or plot the first point, take the reflected point, which is here, 1 1, yes. Okay, on the other side the same point. Okay, good teacher, it is good, it is look like good. Okay, good. Now the second point is 2 and -12. Okay, let's go. This is 2 and 1 2 3 6 7 8. Okay, so it will be here. And let me extend this guy, the axis of, sorry, the axis of symmetry, this one, I will extend it. Okay, and reflect the point as we learned. There is 2 at the right, so 2 at the left, so it will be here. Good, I'm finished. Yes, I'm finished. Now I have to connect. Okay, I have to connect. How I connect them? See, before I connect them, you have to make sure from something. You go back to the question here, to the original question, which is here. Is there any plus something here? Answer me. You have add or subtract something here? No, teacher, you don't have, we don't have anything here. So because of that, you have to connect in this way. You go to the origin, you from here, you start from here and connect like this, and go back to the origin and connect like this. You see? Are you happy with that? So it is coming down. Teacher, you say the parent of any quadratic is it is like this. You said for us before 1 minute. You said y equal x square is the parent. Yes. Why this coming down? My dear student, you don't see? It is a negative. It is negative coefficient here. See, it is negative. So teacher, if it is negative, it is coming down? Yes, my dear student. If it is negative, it is coming or it is going down. Are you happy with that? Okay, good. Now, he will ask me about the domain and the range. Are you ready? Or before the domain and the range? Actually, it has this called vertex, and this vertex is 0 and 0. And this vertex, it is maximum, or maximum vertex, or maximum point. How it is maximum point? Because it is a maximum point regarding to all the points that living on the graph. You see, it is come in the top. So my dear students, if you have a function, a quadratic, and this quadratic, okay, it has a negative coefficient, so the vertex maximum. Okay, good. Okay, and if we don't have, also stay with me, if you don't have a plus minus something here, the vertex all of time it is 0 and 0. Okay, good. Okay, one more thing. He will ask me what is the domain and what is the range. Okay, the domain for all quadratic function, your answer must be real numbers, are all the real numbers. Okay, all the real numbers, or you write like this, or you write all real, not Madrid, or real numbers, not only. Okay, now what is the range? Okay, you read to start, the range is starting from vertex. This is the vertex, and it is go down. As you see, it is the graph, it is go down. Yes, you see. So the vertex is 0, so it will be from 0, and go down, it is negative infinity. Good. Teacher, if it is go up, it will be positive infinity. We will take another example. Don't worry about it. Okay. So teacher, if the range will be 0 to the negative infinity. Yes. Now, if we don't have a graph and ask me, give me any question here, like this one, and he didn't graph it, and he asked me about the range, how I can find it? The domain we know. The domain is R for all quadratic. We done from it. Now the range, how I can find it from the quadratic? The range, you say the range. Okay. Okay. You write, you start. You don't have positive, negative, any number here, so it starts from 0. This is the first problem. The second part, this guy is negative, so negative infinity. Good. So teacher, if this part is positive, for example, it is 3x squared. So it will be, what is the range for this? My dear student, the range, the domain is R, okay, and the range for this one, okay, you start as I learned you. It has no adding or subtracting any number here. So you start from 0. And because this is positive, so it is positive infinity. Are you happy with that? Me too. Let us graph another one. Now, let us come back and tell you something here. Teacher, I will take the 1 and the 2 for all. I will select 1 and 2 for all function. Actually, yes. For all function like this, for example, 2x squared, I will choose 1 and 2. But if you have a fraction like 1 over 2, okay, I will select another value. For example, 2 and 4. Why 2 and 4? Because the 2 and 4 is the multiple of 2. But if this is 3, teacher, what I should select? I will select 3 and 6. Why? To get a nice number. Okay, my dear student? Okay. Now let us take one more example and your life will be good. Now let us take number 4, y equal negative 2x squared minus 1. Or no, I will take the upper one, 1 over 2. I will graph this. First of all, what is the two numbers that you will pick? Teacher, regarding to this, I will take 2 and 4. Good. Now, how we can substitute, yes, substitute this number instead of x? How we can? Easy. We do like this, 1 over 2, and the 2 will be squared plus 2. And how I can calculate this? This will multiply by itself. It give me what? 4. And the half of 4 is 2. and 2 plus 2 equal 4. We done. Now 4 term, I put it instead of x, so it will be 1 over 2 multiplied by 4 square plus 2. So I just replace the 4 by the x. Now don't say 4 multiply 2 here, I will kill myself. Okay, it is 4 by 4, not 4 by 2. Remember, square means multiply the number by itself, so it will be 16. Now 16 multiplied by half, so it is mean 16 divided by 2, and this give 8. 8 plus 2 equal 10. Don't forget to add the 2. Okay, it is one factory, okay, or it is one function. So we done. Now we go to the graph. Now I have 2 and 4 and 4 and 10. From where you get this number? This for this and this for this. This for this and this for this. And you remember this, or what I have to say now, this number is left or right. Positive for right and negative for you have to move left. Let us start. Now I will graph in this. I will extend this, my dear student. Okay, I will extend this like, okay, I draw the axis of symmetry. Actually, this is called axis of symmetry. You know that, yes? Okay, doesn't matter. Let us start. I will clean some of values here, and here I will do it, fix it again. Teacher, why you don't graph in another graph? Okay, this doesn't matter. Okay, I need to keep this actually. Okay, 2 and 4, let's go. 2 to the right and 4 up. 1, 2, 3, 4 here. So I'm done from 2 and 4. Okay, but before you move here, go and reflect 2 and 4. How I reflect it? I see how many steps far away from the axis of symmetry. It is 2. I draw the reflected one in the other side, so it will be here. Hard? Easy, yes? Now the second point is 4 and 10. 4, 1, 2, 3, 4, it is 5, so this is 4. And 10, I have to move up 10 steps. Oh, sorry for that, please. 1, 2, 3, 4. It will be here. Oh my God. Okay, it's 7. So 4 to the right, I have to draw 4 to the left. So it's supposed to be here. Okay, so this is the reflected point. Are you happy with that? Are you happy with that? Me too. So it will be here. So each point I plotted, I graph, I plot the reflect. So instead of 2 point I find actually I graph 4 points here, or 4 border pairs. Now the most important thing here, you have to go back to the graph before you connect and check it is a plus. There are any plus here? Yes, plus what? Plus 2. So you have to count 2 up, so you have to start from 2. It is 1 and 2 from here, and connect the point as you know before. So this is the first connect, and this is the second connect, and we done. Okay, now he asked me about the domain and the range. The domain is R or real numbers. What is the range? Okay, where is the vertex, my dear student? The vertex is here. And what I have here, as we said before, it is 2, teacher. And from where I get the 2? From here. Okay, so the range is start from 2. Okay, it is starting from 2 to where? To the positive infinity. Why positive infinity, teacher? Because it is move up. So teacher, if I move down, I get negative infinity. And if I move up, I get positive infinity. Yes. What else? So I will start the range from the vertex. Here I start from 0, and here I started from 2. And the 0, because there is no plus in the function, and the 2 I bring it from here. Yes. So without graphing, I can get the uh, the range from here. So the range is, it is from 2 to positive infinity, because this is positive. Okay, are you happy with that? Okay, one more thing, my dear student. If this, you have to know there are a skinny graph, and skinny u and fat u. For example, if the coefficient is a fraction, as you see here, the skinny, it will be, sorry, fat graph. It will be fatty graph. Okay, how is fatty graph? For example, it will be like this, big, if it is a fraction. If it is a whole number, positive or negative, it will be skinny, like this. Okay, my dear students, are you happy with that? I hope so. Okay, now can you tell me now, the vertex is here, the vertex here is maximum or minimum? How I know, teacher? You know by graph it in fast way. This is positive, okay, positive. Doesn't matter the fraction or number, it's positive. That means it is like this. So the vertex is minimum because it is in the bottom, so minimum vertex. Okay, so teacher, if it is negative, if this negative, you have to graph it like this, so the vertex is maximum. Okay, this is maximum vertex. This is all about 9-1. Thank you for watching, and I hope you get all the benefit, and see you in the next, okay, in the next video. Before we move to the next video, let me make sure you understand, when is the vertex of parabola minimum point? Minimum if the coefficient of x square is positive. Okay, what is the coefficient of x square? I mean the number that stick with the x square. If it is positive, okay, the vertex of parabola will be minimum. Good. Now he asked me, when is the maximum point if the coefficient of x square is negative? Okay, good. Now compare and contrast. How are the graph of similar? They are similar because they both of them are negative. That's mean both of them go down. Yes, both of them go down. This is the first one, and This is the second one. The second one different because he start from where? Positive one. So this is a positive one, for example, so it will be like this. Okay, so similar, both of them go down, and different, one of them, the vertex, here, sorry, okay, the vertex in the first one here, okay, okay, sorry, give me a second, please. I'm finished, almost finished. Okay, thank you. Okay, it is not working. Okay, that's fine. The vertex in the first function is 0 and 0, and the vertex in the second function is what? Is what? Again, the vertex in the first function is 0 and 0, you see? Okay, but the vertex in the second function, it is 0 and 1. Okay, this is the different and the similar. Thank you for watching, and see you in the next video. Goodbye.